I'm Rodger Baker, Executive Director of the Stratfor Center for Applied Geopolitics at RANE, a global center of excellence for geopolitical intelligence and analysis. Learn how you can put geopolitics to work for your organization at ranenetwork.com. Welcome to Applied Geopolitics, the podcast from the Stratfor Center for Applied Geopolitics at RANE. I'm Rodger Baker. As a key technology area, AI, or artificial intelligence, is the target of intense competition between the United States and China, both in the development and use of AI models and in the underlying physical technology behind advanced computing. AI and machine learning appears to be revolutionizing all aspects of international business, including geopolitical risk, whether we consider AI as a disruptor in and of itself or as a tool to assist in anticipating the future. Today, I'm joined by Alina Park, CEO of Ekho Labs. Ekho Labs builds predictive intelligence for global disruptions. Welcome, Alina.
Hi, Rodger. Thank you.
So glad that you're here. It's sort of the first in a series that we're going to be doing on looking at some of the technologies and the intersection of technology with geopolitical risk and geopolitical dynamics. And so I wanted to start off with you. Basically, give us a little bit of understanding on how you're approaching this field or the challenge. So what is it that you define as the challenge of geopolitical risk, and how are you bringing technology to that?
Yeah, absolutely. So let's talk about supply chain risk in general, or geopolitical risk. Within the concept of AI forecasting, we define it as the probability and the impact of the global disruptions that will affect the supply chain itself. The AI models are used to detect, predict, and help people adapt to it. The way we approach this is we are looking at the early signals of physical risk or be that natural disasters or geopolitical risk. We're finding those early signals. We are building the what-if scenarios of how will they ripple, how will they affect the supply chains or the companies, and what should we do about it.
And as you look at these, how important is it to look at history, at historical examples, and how well do examples from one region or one area track and fit against other areas or other geographies?
Yes, so I would say that in a broader sense, it is extremely useful to look at the historical data, obviously, just because as we're using AI, what AI is the best at is pattern recognition. So it is capable of looking downwards back 20, 100 years in history, looking through the metrics and kind of associating what led to what are the correlations, what are the collisions. It obviously creates this sort of bias when it comes to geographical or cultural differences. So it is basically our job as machine learning engineers to make sure that the bias is reduced. One of the things that we can do there is we can look into the similarities between the geographies where the events have happened before. So in the cases of the tariffs in the US and the previous case of the UK with Brexit, what we can do is we can look on how similar the UK is to the US if we simplify it, which helps us to assign the probability or the weight to that event and how that historical event specifically affected our forecasts into the future.
So I always promote to people entering my field to also read things like science fiction, right? And of course, Asimov has the Foundation series. And at its core, the Foundation series is sort of the pinnacle of how machine learning and AI can predict the future accurately, effectively, with massive amounts of information put into it. Where would you rank where we are today versus, say, 30 years ago versus potentially 10, 20 years in the future? Maybe we're not matching Harry Seldon and his box, but where are we along that line of the possible, the actual, and sort of what's really plausible in what we can see as being effective or reliable going in the near future?
Yes, so within risk management, one of the biggest hypes that have appeared recently has been the digital twins, which, just for the background, digital twins have originated, I would say 20 years ago, around 20 years ago, early 2000s. What happened there was that we started simulating physical systems, so it's engines, heavy machinery, anything else. We were trying to create this digital replica of a thing and see how the simulations, basically see if the simulations are capable of providing us with the what if scenarios for those very specific smaller systems. And then over time, we kind of grew that. So now digital twins are powering more of like a system level modeling. So that's energy grids. People are trying to replicate human bodies, smart cities, and in the cases of supply chain, it is also usually a smaller part of it, so like one factory or one lane. So this is kind of where we came from modeling very small things to where we are now when we're able to model a very specific segment of a chain. Where we're going into the future is, even though all of those things are pretty great, we can do maintenance, we can do quality control with them, and some sort of smaller stress testing. What we need in the context of a less stable supply chain is more of a strategic digital twin. So what we're trying to do right now is to make AI help us build a more global macro-scaled strategy to kind of model it end to end as opposed to segment by segment.
And as you look at building this, what are the kinds of inputs or the kinds of events that you look at as potential disruptors or enablers? I guess would be the positive side of change as you're building out some of these virtual models of systems.
Yeah, so for those things, we can obviously integrate all of the data that has been used in risk management before, be that freight indexes, any shipping information, the AIS data. Weather data is extremely useful as well, just because it allows us to understand if there is going to be some sort of a natural disaster in the area. One of the things that have been extremely useful when it comes to geopolitical risk has been social media data. There are a couple of examples that I can give you actually on that end, if that's helpful.
Oh yeah, it certainly is, and especially in traditional geopolitical risk or political risk, obviously social media has become more and more important. But of course, we also have the challenges of how do we keep up with it, how much is out there, and how do we measure its accuracy. But how are you integrating or using it?
Yeah, so the way we use it is we're integrating social media as, I would say, two main components. The first one is the early signals, and then there are things like when the Russian invasion has happened, the early signals has actually have appeared in early 2022. The military logistics, the social media chatter combined actually created those very early signals, and researchers within the NLP, natural language processing industry, have known that the invasion is likely to happen. And the same things happened with COVID. What we do is we performed very similar research when we backtested a lot of those tools, and we're using very similar tools to reveal those unseen patterns to detect the early signals of any disaster, whether that's natural or a geopolitical conflict. And then what we do it on top of the early signals is we use things like very basic sentiment analysis, or we identify the topics floating within the social media chatter to identify additional risks. So there's early signals plus monitoring when it comes to social media.
And just off the top of your head, are you seeing parts of the world or places where the social media, the sentiment indexes are stronger predictors, and places where they're sort of less valuable? Or overall, given the vast quantity, is it sort of equal across the board?
There are definitely areas where it is much easier to track social media engagement just because of the number of people that exist on social media. So the US, for example, has a very high population. huge population, and at the same time, a lot of people are using the social media that are known to all of us. So it's Twitter, it's Reddit, places like the US, and in some ways even China, Western Europe are much easier to track, solely because there are a lot of people who are engaging in conversations on social media. When it comes to countries, and I'll throw this under the bus, Central Asia, for example, it is a little harder. The languages are more mixed. They're very specific slangs, jargons that are a little harder to track. And then the social media communities basically spread around different channels. Not everyone's using Twitter. Some are posting on local social media, etc. So those locations are a little harder to track. That said, we still get the early signals from them.
So I guess that kind of the differences and the regional differences and things like that. How do you see this type of technology assisted, we'll put it that way instead of technology replaced, but technology assisted futures analysis fit with traditional, maybe more qualitative ways? I mean, people like to joke I'm more of John Henry and I'm just going to go bang with my hammer, and then somebody's next to me with the steam drill or now the AI powered machinery running by me. But how do these two methods of approaching things either complement each other, or is AI ultimately going to be replacing, have the capability to replace that human understanding component of futures analysis?
Have you heard of AlphaGo?
Yeah.
Okay, I think that AlphaGo is a great example, just to hop off its back to answer a question. So I'll just give a brief context for the audience on what AlphaGo is. It is a tool that was created by Google's DeepMind 10 years ago. The AI model beat the world champion when it came to the game of Go. And I think that there are a lot of things that we can learn from that example when it comes to qualitative human analysis versus the quantitative AI analysis, even when it comes to geopolitical risk. The things that we definitely learned from that is that AI is extremely good at pattern recognition and at calculating the probabilities. So everything that is quantifiable, awesome, great. We can create all of those, the infinite number of possible outcomes, and we can quantify which one is more likely and which one will lead to another. The things that AI is not good at, on the other hand, is exactly what people are great at, which is judgment, context analysis. And then there are a couple of parts of it that I see that imply that people and AI should work together. The first one is obviously the ethics. People have the emotional intuition, people are more creative, and people know exactly what the goals are. AI thinks that the goals are whatever the ML engineer told them it is. So if I tell the model that our goal is to, whatever, increase the revenue of a specific company, then this is what the model is going to do, and this is how it's going to plan everything without accounting for any human values or our priorities as a community. What people provide in that sense is exactly that, judgment and priorities. And then the second thing is obviously that AI cannot fully replace people like RANE, people like you. There's not enough context, and human experts allow us to understand what to prioritize, what to look at, and where to look for things. Because AI models need data, we need to know where to look for that data. And even though we can make assumptions on this, we always need this human in the loop to kind of guide us into this and then guide us out of this to make the final decision.
Are there, and it's always, by the way, just uplifting to hear that people still matter as we do this. But I guess two things that come off of that. One is we're seeing this emerge as a tool for anticipation, for risk management, but we're also hearing a lot about it becoming a tool for decision making for governments, for things of that sort. Is there an odd loop that gets formed if these tools are making the decisions and trying to anticipate the decisions? If the tool is making the decision, does it not necessarily Is it harder to predict what decision it will make because the tools monitoring are trying to understand past patterns, if that makes sense?
It does make sense. So I think that it is not impossible to understand what the tool is going to suggest people do, simply because the tool is always suggesting people do the thing to achieve the goal that was set. It is a little harder for people to predict it solely because, for a regular person, that is, not the engineer who programmed the model, to predict what the model is going to say solely because the model, again, is ruthless in some ways, where the model will tell you to do exactly what to do to achieve your goal. And then, yeah, again, what people are needed for is value alignment. The model will tell you how to achieve it in the fastest way possible. But if the people don't tell the model to look for additional things, such as the ethical values of the operator, it would not look into this. So yes, it is a little hard to predict what it's going to say exactly, just because this is not how people think. We are still emotional beings, but it is not impossible because there are ways to look into how the model is thinking, because this is kind of the engineer's job to make sure that they understand it.
And when you look at these models, and of course they're trained on now increasingly more and more on real-time data rather than just on historic data, obviously there's a lot of discussion on the bias of models based on what they're trained on or not. Is that not merely from an ethical perspective or a moral perspective? Are there geographic differences in the ways in which the models, for lack of a better word, think, anticipate, or act because they're drawing on different geographic data sets, or are we at a point where it's easier to draw on global sets?
I would say that it is still an issue when it comes to the bias coming off of the training data, especially when it comes to things like we've just mentioned, that the US and Western Europe is going to be more heavily presented in the training data set. So obviously there are some biases. Those are the additional things that us as engineers are meant to take into account and make sure that we can tweak the model. Yes, those biases definitely appear. And then what we do is we tweak things here and there. We sample out the data. We create synthetic data in order to fuse it into the model and make sure that the model is less biased when it comes to countries or geographical areas that are less represented in the corpus.
As you're building out these models, training, refining, and things, are there other fields that have been more actively applying AI? Finance obviously comes to mind. Everyone has just wanted mathematical models to make all their trades anyway. Are there other fields, and how do those correlate to what you're doing in what is often maybe a more qualitative than quantitative space when we're thinking about broad-based future risks to supply chains on an international scale?
So to address the very first part of this question on what are the industries that have done this before, yes, obviously the financial industry and cybersecurity industry are one of the best examples when it comes to forecasting, just because those industries have developed the ultimate playbook basically for the rest of the industries when it comes to risk management. There are a lot of things that we can actually learn from them, or borrow from them, whatever that is. And I think that the playbook that they defined includes things like cybersec, for example, focuses a lot on identifying the critical vulnerabilities, so they know in advance on what is potentially the weakest point for the system. They focus on building that out. Then they're doing the data-driven monitoring and intelligence, and actually both finance and cybersec do that as well. So they're trying to create those interdependent nets of entities where everyone is monitoring the data real time and sharing it with each other, which is, I think it's called threat intelligence sharing, exactly, so quite understandable. What they do is they identify all of those weaknesses, they share them with each other, and then they build this stress testing and scenario planning. So whether that's within the traditional financial industry, trying to predict the bank run scenarios or recession scenarios, market crashes, down to a similar thing happening in cybersec. So what the supply chain industry should be doing, in my opinion, especially when it comes to geopolitical risk, would be if we were looking at very similar things, identifying what are the weakest points within the entire chain, looking at all of the existing data, multi-model across different types of data sources, whether that's social media or news outlets or shipping data itself, and then thinking, what happens if this happens? What happens if the supplier shuts down? What happens if we have a new tariff? So we could borrow the entire framework of thinking about this and building out the future systems.
So this can be, if done right, you can do it both to stress test and find potential weak points or thin points, and ideally to be able to look forward to anticipate where those stresses may emerge that create those challenges. And what's the at the moment, at least in this broader field for supply chain risk, what's the sweet spot in terms of time frame? So when I think in my work for the last, I don't want to say how many decades, that that in some ways, if I push out to the 5-10 year mark, geopolitical analysis gives me pretty good frames of how the world is going to evolve. It doesn't give me any details, no tactical details, but good frames. If I if I pull back into 3 month blocks, it's a lot more tactical intelligence than broad-based geopolitics. Geopolitics gives it context, but in the shorter time frame, it's quite frankly, it's human variabilities and vagaries. It's very small, almost the day-to-day unpredictable dynamics. And so there's a balance between where is the sweet spot that blends traditional intelligence analysis and broad-based framing in geopolitical analysis. As you're looking at this, what's the lean forward window that seems to be the most useful so far? And how do you see that window either getting bigger or moving in the future?
Yes, so for now, what we're seeing is, especially given the current environment, the forecast of 6 months seems to strike that balance between providing enough of qualitative analysis, but also having enough details to build a quantitative analysis. What we're particularly interested in is, especially when it comes to risk management within supply chain, is what are the very specific impacts. And in order to understand those impacts, it is extremely useful to know the current volume, the current losses, and how they will basically build up to the next losses. So in that sense, 6 months by test has historically been the best one. As they are scaling this further, I think that one of the things that, again, we can borrow from the traditional industries when it comes to risk management is that we can collaborate, companies can collaborate between each other. As right now, there are freight indexes that are combining several different metrics. We could do very similar things when it comes to data on risks between different companies. So if the semiconductor industry got affected, those companies could report it, whether that's in a public setting or in a private setting, sharing between their partner companies. The reports on their actual losses could build it up to extend the data set and to basically improve the quantifiable analysis, so that basically the more data we get from the actual losses, the more we will be able to extend the forecasting timeline. For now, the 6 month, I expect it to grow to 12 months in the near future, and we'll see how that goes forward.
What swinging back to the types of risks then that you're talking about in here, what are some of the things that you see as the key risks to supply chains? And I don't want to make you into force you into the my job of of qualitative analysis, but what do you see as the areas that potentially, as you're looking and as you've been working with the data and working through this, that are likely to be either more disruptive or more volatile, going forward, that is either challenging or making your models more effective?
Are you asking me in the broader sense, or do you want
In the broader
specific
sense, we
examples
don't
in
need
the
we don't
broader
need
sense?
specifics. we don't have to dig into that, but just thinking about
Yeah.
these broader contextual elements that fit into this.
Yes. So what we were looking into lately and what has been quite interesting was that there are obviously those broader problems by industry on the demand. We were just looking at the cold storage and perishable goods. There are a lot of things that the current risk management system is incapable of predicting when it comes to industry-specific analysis with their very specific needs, just because the current risk management system is focusing on visibility. So it is becoming increasingly hard to take into account all of the smaller things. People forget that we need a refrigerator to move some things around. Then I think that the second thing that is very interesting to look into is the correlation of those very specific demands to the capacity, which also is allowed solely with the data, which is quite interesting. The biggest bottlenecks that I see when it comes to like a broader term, I think are the cases of operational disruption when it comes to labor. So whether that means that we don't have enough truckers or that we know that the port employees decided to go on a strike, those kinds of human bottlenecks, if I can call them that way, are one of the things that are less taken into account right now, just because those seem to be smaller issues that appear very locally. But at the same time, those smaller local problems can cause huge disruptions because they will appear at a significant port. And then there are obviously very specific things such as the tariffs, the civil unrest appearing due to the macro-scaled issues rather than the micro-scale issues that are unrelated to supply chain. I think that the whole thing with navigating how one area of risk is affecting the other is something that we overlook right now, and I think that this is going to be causing us the biggest problems in the future. So in your case, what you're doing with the qualitative analysis is exactly what is helping to tie those things down together when it comes to the broader 10-year time frame. I think what we're lacking right now is the ability to put the numbers with that qualitative analysis when it comes to all sorts of risks and how they are tied together.
So we're coming to the end of time, and I just want to give you a chance to talk about a couple more things really quick, if you have a moment here. I guess two things maybe to close us up on. One, I know that for years I've done little tests here and there and been asked to test out as technology to supplement or assist in my work as comes out, and for the most part it always appeared to be a higher cost of input time than what I gained out of it. But in the last couple of years, the ease of interacting even with basic, GPT type models and things like that seems to be making this more accessible. How from the outside in do I judge whether being more interactive and accessible actually makes it better? Is the quality output better just because I can talk to it versus have to type in pages and pages of data and see what it spits out? And then I guess the second, to give you just a last little bit to close is, how did you happen to come into this intersection of supply risk technology dynamics, if you want to spend a minute on that? Because I think that would be an interesting, how do these fields start to merge as we're thinking forward?
Yes, so to address the first question, and I think that it absolutely allows us to summarize what we've just talked about. Yes, you don't really know how much better did the models get, and I don't want anyone to trust that the models got better just because now we have a nice little chat to talk to, a little chatbot. That is obviously not enough. What we actually need is to make sure that there is a quality assurance when it comes to the data quality itself. If the models are trained on bad data, they will also produce really bad results. We want the model to give as much transparency to the people as possible so that you don't just trust my word on it, but you actually know the methodology and you can check it yourself. And the last thing is obviously we, as people, need to remember that the models are amazing when it comes to all of those planning of different scenarios, thinking of a million different scenarios at a time, quantifying how they work, and reading as much data as possible that us as people might be too emotionally exhausted to read, might not think about it with a cognitive load, or simply might not have enough time to go through millions and billions of data points. So what AI is great at is exactly those things. If we ensure the quality of the data on the input and we ensure that the methodology is followed, what you can do as a person is to take this as, okay, this is 10,000 analysts at a time creating a single report for me. Do I trust it 100%? Not necessarily if I'm a smart person. What I will do instead is I will use this very usable chatbot interface to make sure that I understand every point that was made and to make sure that I can poke holes into this. You can ask it questions, you can ask for a very specific data set to ensure it yourself, to recalculate, whatever you want to do with it. My point there is that you don't need to trust it. We have gained very significant progress in the past 20 years. But it is still something that needs to be human plus AI working together and making sure that the quality is there. And when it comes to the way we arrive to using AI in supply chain, my focus has always been on natural language processing. And I got interested in identifying those early signals of disasters a couple of years ago. We did a couple of research papers and research projects with Stanford researchers and a couple of companies in the industry. And what we found was that it is actually becoming increasingly easy to identify those early signals a day or a week before the events happen. And I don't actually know if you know this, but the way I stumbled upon the application of those early signals, whether that's geopolitical risk or physical risk, the way I stumbled upon the application of this within the supply chain was by reading the Zahan's book on The End of the World is Just Beginning, which is also how I got introduced to Stratfor as a company. I was looking into the most tangible applications of those early signals because I wanted to make sure that they deliver as much impact as possible. And then I stumbled upon the book and it changed my life a little bit. So I reached out to you.
Well, interesting, and it's always interesting roundabout routes, but this is really been helpful and fascinating. I know that there's a lot of for those who are not intimately in the field, it's very hard at times to discern a hype from advancement. And being able to sort of ask and query and get a little bit better understanding both of the capabilities as they're advancing and of the limitations. And I think, as you point out, maybe trust but verify, or treat it as you would any other bit of information. You need to assess it, you need to test it, you need to move forward. But certainly the ability to draw on much larger data sets would have made my life easier a lot in the past, I know.
Yes, no, I agree with that. And then any early signals give us just enough lead time to make our own decisions. We don't have to fully rely on AI, but we can work with it.
Right, and that lean forward, I think, is ultimately what becomes the most critical. Is can we find ways to showcase indicators of change and direction of change before that change occurs, so that we're not running around explaining away black swans, but instead we're able to anticipate, assess, and act prior to, or at least earlier in the cycle, rather than later.
Exactly.
All right. Well, I want to thank you for joining me today, Alina.
Thank you, Rodger. Thank you for inviting me.
All right. And we have been chatting here with Alina Park, the CEO of Ekho Labs. If you'd like more risk insights and analysis, you can visit ranenetwork.com. That's RANE network.com, where you can learn more about our suite of risk intelligence products. Thank you.